Hey, how's it guys? I'm going to be running through the TUT questions for week 9 today. It's not going to waste any time, jump straight in. Okay, we've got question 1. A sample of 30 sales records. Okay, so as you read through the question, I'd suggest, like I do, you write down what they give you. Okay, so they give us a sample of 30 sales. We know one of the ends is going to be equal to 30. Sample of 30 sales records from a convenience store is a mean of 142. Okay, so we know x bar, because it's the mean of the sample, is equal to 142. Okay. It is known that the standard deviation of sales receipts in the stores is 34 rand. So we know the population standard deviation is 34. So we know standard deviation is equal to 34. Use these values to test whether or not the mean sales value at a convenience store is different from 148 at the 5% level of significance. So here's our key thing. They want us to test whether this mean that we have from these 30 sales records is going to be different from a mean of 148. So we have to assume that the population mean is 148. Okay, and so we're going to of course be doing this hypothesis testing. So what's our first step? Our first step is going to be writing down what our H0 is, what we're going to be assuming. And here we're going to be assuming that the population mean is 148. Awesome. Now, H1, we have to write down what our alternative hypothesis is. Now, of course, because they say is different from 148, we're going to have not greater than equal to, but just not equal to 148. Okay, awesome. Third step, we know our significance level. Level. At the 5% or 0.05. And the corresponding value will be either negative 1.96 or positive 1.96. And the way you find this out is you have a look in the tables for the 2.5% point, and you take the negative and positive of that, because anything to the right of that or anything to the left of that will have 5%. Awesome. Okay. We can now find out what our z value is. So z is equal to x bar minus mu over sigma over root n. We've got an x bar, 142, so 142 minus what we're testing, because we're going to be assuming that the population mean is 148, so minus 148, over the standard deviation, 34, over root 30. There you go. So we go pop that into our calculator, find out what we get. So 142, start maybe with brackets, 142 minus 148 divided by 34 divided by root 30. There we go, and we end up with it's equal to negative 0.967. Okay, with a bit of rounding. So what can we say? So this value lies within the value that we've just found out. So at the 5% level, we know the lower bound is negative 1.96 and the upper bound 1.96, negative, positive. This lies in between. So what can we say? Because this lies in between this range, the range being defined at the 5% level, we cannot reject H0. So we do not reject H0 because it lies between this value, and so we can say that there's no change in the mean. So no change in mean. Also, very important, maybe also, we do not reject H0 at 5% level of significance. Put that down, but for this course, because you're doing multiple choice answers, I don't think it's going to be that problematic. Okay, awesome. So that's question 1. So we're not going to be rejecting it. We've just tested it. What you can also do is you could possibly find out what the p-value is. Did I ask for the p-value? Oh yeah, that's the second part of the question. Test the hypothesis and establish the p-value. So what we're going to do, we have our z value, negative 0.967. What we're going to do, we're going to look up that value. Now remember, because the tables we have only talk about the positive or the right-hand side of the standard norm, we're going to have to look up the positive value. Okay, so with a bit of rounding, we're going to round that up to 0.97. Okay, So we're going to be looking down 0.9. We've got 0.9 all the way across to 7. There we go, 0.334. Okay, awesome. Okay, so we end up, corresponding value for that is 0.334. Now, of course, because we're looking at the other side, because we're looking, remember, if we draw our table, or our graph of the distribution, it's around 0. We've just looked up 0.97, and that's told us this value. We, however, want that value. So how do you get that? You just do 0.5 minus 0.334, and that gives you 0. And let's pop that into the calculator, just to find out 0.5, oops, 0.5 minus 0.334, 0.166. Okay, I've also left one thing out, because this is a two-sided test, not a one-sided test. Remember, it's a two-sided because we're looking at greater than or less than. We have to multiply this by 2 as well. If it was a one-sided test, that'd be it, but because this is a two-sided test, it's times 2, so times 2. Let's get pop times 2. 0.332, and I think it's just by chance that these two values are very similar. I don't think you're going to be ending up with, this isn't the norm, if I can say. But there you go. There's our p-value for this. Okay, awesome. Okay, so that's question 1 done. Cool. Okay, let's move on to question 2. Organize a bit. Okay, so we're looking at an amateur long distance runner knows his time taken to complete a 10-kilometer race. Has a standard deviation of 1 minute and 51 seconds. So we know the standard deviation is equal to 1 plus 51 over 60. Because remember, 1.51 is not equal to 1 minute and 51 seconds. Remember, there are only 60 seconds in a minute, so that's why we have to divide it by 60 to find out how many minutes are in 51 seconds if we're looking at the decimal points. So you're going to have that. The runner claims that his long-standing average is 42 minutes. Long-standing average, I think that's the key word there for population mean, so we're going to have 42 minutes. If for his last 15 races, we've got an n, is equal to 15. He averaged 41 minutes and 5 seconds. So we've got an x bar as well, of 41 plus 5 over 60. Is this evidence that his mean time has improved? Test the claim at the 4% level of significance. What is the p-value for the test? Okay, so I guess the key question here is, what does improved mean? What does it mean to improve? Improved doesn't mean that your mean is going to be higher. It's going to mean that your mean is going to be less. So if we start off with writing our H0 or null hypothesis, we're going to be testing whether mu is equal to 42, which is what he's told us. And we're going to be seeing if his time has improved. In other words, is his actual mean less than 42? And so this is a one-sided test. Because we're just looking at less than. We're going to be looking at 1. We're not looking at different from 42. Okay, awesome. They've also given us a significance level of 4%. And if you look up on the tables, the values that should correspond to is minus 1.75. Remember, because this is a one-sided test, we're only looking at one side, whereas with the previous question it was a two-sided test, which is why we had to split our values. So we're looking at anything less than negative 1.75. Okay, cool. That's our boundary. We're going to jump straight into our test statistic. Z is equal to x bar minus mu over sigma over root n. And that is equal to, we have to do some calculator work, 41 plus 5 over 60 minus 42. Nice and easy. We then have 1.51 over 60 over root 15. Yep. Okay, so pop that straight into our calculator. We've got 41 plus 5 over 60. Maybe put one more bracket in there. Subtract 42. Awesome, we divide now by 1 plus 51 over 60. We divide that by root 15. Let's quickly go check. Properly. Yep. Okay. We go pop that. Okay, and we end up with negative 1.91. Or sorry, let's round that to 2. So it's equal to negative 1.92. Okay, bit of a rounding thing. Okay, so we see that this value is less than our critical value, which we found at the 4% level of significance. And so because this, our Z value, which we looked up now, is less than the critical value, we're going to reject H0, and we are going to say that the mean time will be less than 42. Okay, so because this is less than that, we reject H0 and find that his mean time, I think it is a male, I'm not too sure, yeah, his, okay, his mean time has improved. Sorry if my handwriting's not great. Okay, so we reject H0. Oh, I forgot that last bit. At the 4% level of significance, and find that his mean time has improved. Okay, so because this value is less than that, we're going to reject H0. H0 being, there we go. Okay, now we're going to find the p-value. Going to do exactly what we did in the last question. We've got negative 1.92, so we're going to look up 1.92. You guys can follow me in your intro stats if you want. Okay, so we've got 19, and 2, so 0.4726. 4726. Okay. So you find 0.4726. Is that right? Yep. Okay. Perfect. Happy with that. Cool. But now, what are we looking at? What are we testing? We're testing that it's less than this value, right? Because we're looking at, less than that value. So we're looking at everything to the left. If we draw a graph again, right? This is 1.92, and this is negative 1.92. This is the value we've looked up, but we want this value. And so we're going to do 0.5 minus that. And that's going to be equal to 0.5 minus 0.4726, 0.0274. Sorry, getting a bit tight. Okay, so that's our p-value. Our p-value that we looked up. Because we're looking at for less than that. So anything to the left of that. If we were looking at greater than, we'd be looking at all of that. So all of this plus all of that. But we're just looking at this end over here. Okay, awesome. Not too bad. Now we're going to move on to our last question, question 3. It's quite a meaty question. Okay, so we have a pharmaceuticals company wants to test the effectiveness of a new drug for a particular infectious disease. In a random sample of patients with diseases, 24 were randomly assigned to receive the new drug, while the remaining 16 patients were given a placebo. So here we're going to have two samples in essence. So we're going to have N1 is equal to 24, have N2 is equal to 16. This is going to be 2 is going to be placebo, 2 is going to be actual drug. The length of time the infectious disease lasted was recorded by a doctor for each patient. Okay, so he's recorded the time that the disease takes. The sample mean for the group taking the new drug was found to be 6.5 days. So we've got X bar 1 is equal to 6.5. And for the control group, group 2 taking the placebo, the mean was 7.125. So X bar 2 is equal to 7.125. The population standard deviation for recovery times for people with the infectious disease is known to be 1.2 days. So we know if you have the disease, you will the standard deviation of that is 1.2. Here we have everyone has the disease. It's just group 1 is given the actual drug and group 2 has been given the placebo, but everyone has the drug. Has the disease. Test the claim that the drug reduces the time that an infectious disease lasts at the 5% level of significance. So reduces time, we're going to be looking at less than, and it's going to be a one-sided test, so keep that in mind. What is the p-value for this test? What assumptions do you need to make for the test to be valid? Okay. Awesome. Okay, so maybe let's just start with the assumptions. So what assumptions are we going to need to make sure that this test that we do is valid? I'm going to give this one to you guys straight. We just have to assume that both groups, or both disease times are normally distributed. So they both follow normal distribution. So that's going to be a little side note over there. Okay, that's out the way. Cool. So we have our test, right? Our test is going to be drug reduces time that an infectious disease lasts. So we're going to have, starting off with H0, we're going to assume that there's no difference. There's no difference, i.e. that mu1 is equal to mu2. The mean of the group 1 taking the drug is equal to mu2, the mean of the group taking the placebo. H1, we're going to be looking at this drug reducing time, so we're going to have mu1 is less than mu2. That's our H1, our alternative hypothesis. We've got the significance level of 5%, and that corresponds to a critical value of less than negative 1.645 or negative 1.65. I think for you guys, when you guys write the tests or you do assignments and such, finding this one side 5% level, I think you can use negative 1.645 or negative 1.64 or negative 1.65. I'm pretty sure about that, because if you go and look in the tables, it's not exactly too clear. So don't stress about which number you need to exactly use, because for this, the 5% level, we've got a bit of leeway for you guys. Okay, awesome. We've got a critical value. Now we just need to set up our Z. So we have Z is equal to x bar 1 minus x bar 2. X bar 1 minus x bar 2. Then, minus mu 1 minus mu 2. And of course, because we've assumed they're the same, you're just going to have a 0 there. Nice and easy. Because they both come from the same population, i.e. they both have the disease, they're going to have the same standard deviation, so it's going to be 1.2. But because they're different sample sizes, we're going to have to do 1 over 24, 24 being for group 1, and 1 over 16, and we sum these two together. Awesome. Okay. Oh, sorry, I forgot to put in values over there. Okay, so that is equal to, got 6.5 minus 7.125, or two values up here, minus 0. Happy with that. 1.2 times the square root of 1 over 24 plus 1 over 16. We're going to pop this straight into our calculator. Okay, so we've got 6.5 minus 7.125 divided by 1.2 times the square root of 1 over 24 plus 1 over 16. We've got enough brackets in there. And there we go, and we end up with a value of negative 1.61. Awesome. So, we see that this value is greater than either one of these. Doesn't really matter, but it's greater than. And so we cannot reject H0 because it is not less than negative 1.65 or 64, whichever you use. So we cannot reject. So we do not reject H0 at 5% level of significance. and we find that the drug doesn't reduce the disease time. There's no improvement. Doesn't reduce disease time. Okay, so because this is less than our critical value at the 5% level, we cannot reject H naught. And so essentially what we're saying is that the mean for the drug is equal to the mean of the placebo. So the drug doesn't really do anything. But yeah, okay. P-value quickly, we've got negative 1.62. So we're going to look that up in Le Tables. 1.62, again looking at the positive. 1.6. So it was 1.61 or 1.6? Yeah, 1.61. Sorry, 1.61. 1.61. So we end up with 0.4463. 0.4463. Okay, so we have 0.4463. And because it was our mu1 is less than mu2, we're looking at less than, right? Draw the table, we're looking at that way. We have this number, and so what we do, 0.5 minus 0.4463, and that gives us 0.0537, I think. You guys can double check that. And there you go, that's our p-value for that test. Okay, awesome. I hope this has helped you. This has been week 9 TUT. You've got your test coming up soon, so do prepare for that. Leave any comments or messages if you have any other issues. Feel free to speak to us tutors. We'll be ready to help you. Okay, awesome. Cheers, guys.